we're going to talk about a little bit about how to set up your equipment and observing precipitation, how we do it. The most important thing is, where did you put this gauge, right? So there's some places it's a good place not to keep it. So we don't want to keep it in the box, and we don't want to put it in a place where we're going to get artificial amounts of water flowing into it, like from the gutter on the roof, that sort of stuff. We don't want to put it under a tree, because the tree is going to block us from getting precipitation, or near the porch, or even over here. It's a little bit too close to the porch, so that we want to put it out in the open. We don't want to put it in a place where sprinklers might deposit a little water in there that we might think is rain. We don't want it where the animals can attract it or bother it or drink from it or whatever. And we don't want to put it in a place that's dangerous to get access to. And we don't want to put it in a place that we're going to have something that's going to either make it more or less precipitation that falls into it. If you have a solid fence, what happens is the wind comes along, and the wind hits this fence, and then it's forced to go up. And when it goes up, the wind is going up like this. So if you have your gauge right here, and rain's trying to come down, and the wind is pushing it back up, you're not going to actually get all of that rain measured into your gauge. So we don't want to ever use a solid fence as a place to put the gauge. But if it's an open fence, like a chain link fence or something like that, then it's not a problem. Ideally, you want it in the middle of a big open area. But nobody's backyard looks like this, right? I mean, most people's don't. Mine doesn't. It would be nice, but I don't have that much property. So most people are doing something like that. There's trees or bushes or other kinds of obstacles. And so you just kind of go as best you can in between those. So in an open area, you want to be twice as far from an obstacle as it is high. So if you have a 10-foot tree, you want to be 20 foot away from the tree. But if you have lots of stuff around you and it's not an open area, then you just want to be kind of in between all of your obstacles so that you have as much open space as you can, right? So distance between trees, you kind of got to go halfway between them if that's the kind of situation that you have. The other thing is, you want to keep it kind of low to the ground if possible, because the wind is the higher above the ground you are, the faster the wind speeds. And if the wind goes really, really fast, the rain's falling down and the wind blows it sideways, then the rain's going to be going like this. And it's not as much of it as is going to fall into the gauge. So you want to slow the wind down so that the rain will fall into the gauge. We do that by getting closer to the surface, because the closer to the surface we are, the more friction the wind has as it goes across the surface, and it slows it down. So if we're in a really big open area, just put it really close to the ground. If you have a lot of bushes and stuff around, those will slow the wind, so you can put it up a little bit higher if you have that kind of situation. And then you have to watch out. If you put it on a flat post, what's going to happen is, if I have a flat post and here's the top of my post, then rain's going to hit this top of the post and some of it's going to bounce in. And we don't want what bounces in, we just want what falls into this area. So they bevel the edge of the post so that any rain bounces away rather than into the gauge. So when do we take our observations? We typically, in this whole network, we take the observations at 7 o'clock in the morning. Sometime between 5 a.m. and 9 a.m. is fine. And anything that's read between those hours will get immediately shown on the map when you report how much rain that you had. So how do we read the gauge? Okay, so it's important that we read it properly. And so in Arizona, 0 is pretty much what we're going to get 90% of the time, right? So that's usually the most often thing that you're ever going to see is a 0. But then we have sometimes where we have little traces of water that comes down, and we would call that a trace. It isn't enough to actually measure. So each one of these little increments, the little tick marks, is 1/100th of an inch. And so then we see 1/10 of an inch with a bigger number there, and then 2/10 of an inch. So each of the little ticks is 1/100th of an inch. So if it's not at least 1/100th of an inch, we call it a trace. So anything between a trace and 1/10 of an inch would be in the 100ths of an inch. And so at that point, what they're showing there is 4/100ths of an inch, 0.04 inches. And the surface of the water, it's called the meniscus. And the reason it does this is water clings to the side of the gauge, and it's called surface tension. And so it causes the water to go up the side. So what we do is we read the lowest point. It's the bottom of the meniscus that we read when we make a measurement. And so here's a reasonable range. So this is about just about 0.5 inches, what they're showing right there, and that's in this little gauge inside here. So the top of the gauge has a funnel, and the funnel causes the water to go into this part right here, and all the way to the top is 1 whole inch. And that 1 whole inch is the depth of water we would have over this whole area where we're capturing the rain. They put the little tube in the middle so that they can force it, the 1 inch of water, to look like a taller column, so that you can actually read hundredths of an inch. If you were trying to read 1/100th of an inch in something that was only this tall, it'd be pretty much impossible. So that's why we use this little inner gauge, just to help make it easier to read. And so here's a good rain. This would be 1 inch. So at the top of this gauge, at the very top, at the 1 inch mark, there's a little notch cut in there. And what that's for is after the first 1 inch, all the rest of the water that falls in spills out and is captured into the bigger cylinder. And so there's a comment about decimals. It's important that you recognize the difference between 0.04, which is way down here, and 0.4, which is up here at the 0.4 mark, and then 4 inches, which would be this whole thing plus 3 more inches in here. Okay, so this is a whole bunch more than 1 inch. And so what happens when we do this, it's possible that this whole gauge could hold 11 inches. Now we read this every day, so it's unlikely in Arizona that you're going to ever measure 11 inches in 1 day. In Florida that happens a lot, but in Arizona that doesn't happen so much, pretty much. Every once in a while, there's a couple places that have had that. I think a record for 1 day is 12.97 inches, I think. So what happens is if you have more than 1 inch, you take the first inch and you write it down and you dump it out, and then you take after that and then you pour some of the rest of the water in, and then you pour it up to some level and you figure out what that is and you write it down and you dump it out, and then you keep doing that and writing it down until you've measured all of the precipitation that fell into the big gauge. And so in this case, you just add it up. So they had 1 inch, and then he had 0.97, 0.88, 0.92, and it added up to 3.77, and that's how much you would report. That's not going to be real common here in Arizona. But every once in a while, it sort of happens. Hail. Hail is difficult to observe. Why? Because, as I said, it melts. And so if you get home and it's all melted, you don't know that hail fell, right? How could you tell? So we have some ways to measure hail. And ways that we observe hail. So if you're there and you see the hail, what you want to do is get some device, either a coin. If it's small hail, you would take like a quarter or a nickel or something out of your pocket and you put it down. Or if you've got a ruler, you put that down. So you can measure what the diameter of the hail was. The biggest hail that we ever had in the Phoenix area is 3-inch diameter, right? So that was pretty good size hail. We had that in 2010. In October, that was the same time where we had those tornadoes up in the Flagstaff area. There was like 11 tornadoes, 3 big ones and stuff. Anyway, so we want to measure the average size of the hail. We also want to measure what was the biggest hailstone that you could find. And then we have a hail report that you can get and a hail pad. And essentially the hail pad is a piece of styrofoam covered with tin foil. And so we just get a piece of styrofoam at the hobby shop, and then we cover it with tin foil, and that makes a nice hail pad. And what happens is, I brought another one for you to keep as a sample, but what happens is, as the hailstones fall, big ones leave big dents, and little ones leave smaller dents. And so then what we do is we take this and we send it back to the people in Colorado. The flood control district of Yavapai County can collect these, and then they can send it back. And there's little people in Colorado that take rulers and they measure every one of these little things from the hail pads people send in, and they figure out how big the hailstones were based on that information and the information that goes on the little card that's with it. Anyway, it's kind of fun. But even if you didn't send it in, if you have a hail pad out and you put little like nails, big nails through it to keep the wind from blowing it away, when you come back and you find all this water in your gauge and you see this, you go, ah, we had hail. And you know we had hail and you didn't have to be there. So they're pretty fun devices. And they're real simple to make with just some styrofoam and some tinfoil.